Hello everyone, I'm Snigdha Kakkar and this is my channel Accelerate AI Careers. I'm going to bring 7 questions asked in 5 interviews in last 1 month. So this is quite critical series of my videos which I'll be launching this week, where you'll have almost 35 questions in your bucket which have been asked in last 1 month of interviews. So if you are aiming at cracking any of the 5 interviews, do stay tuned and just help me out. Mention anything in the comments here, whatever you like, whatever you don't like, or just an emoji. It helps with the algorithm of the YouTube here. Our third question is LeetCode 767 Reorganize String. It has been asked by companies such as Amazon, Microsoft, Meta, Netflix, Tesla, Adobe in their last 1 month of interviews. So it's kind of very important question. If you're interested, look at the description of the question first and then pause the video and solve the question yourself. And after that, replay the video and watch the solution I'm presenting here. So I'll be discussing a few approaches. Whatever you feel like is the most optimum approach, try coding with that first and then look at my solution. Let me know how did you find it. So let's look at what this question says. So you have been given a string S and you have to rearrange the characters of S so that any of the two adjacent characters are not the same. That is, an A and A should not come together. There should be a character in between. So you have to return any possible rearrangement. There could be more than one rearrangements possible to do that, but you have to return any one rearrangement that is possible in such a way that no two same characters come adjacent to each other. And if that is not possible, you have to return an empty string. Let's look at a few examples to understand the question better. The question seems very simple on the outside, but it's a very complex question, and I would rate it as a hard level question rather than a medium level question. And that's why it's one of the favorites by many of the companies. So let's look at the examples to understand it better, and then I'll explain you the algorithm behind solving this question. Example 1. S given to you is AAB. The output would be, actually you take A and then put B in between and then A. That way the two A's are not adjacent to each other. This example shows us one approach which we can start with is find the most frequent alphabet and then separate it with the less frequent alphabets. So that's your first hunch while solving this question. But will that approach work for all the strings? So let's look at example 2. In example 2, the string given to you is A. So if you say you take the most frequently occurring alphabet, which is A, and then put a B, and then put an A, but then there is no other option but another A. So there would always be two adjacent A's happening in whatever reorganization you do. Hence, none of the solutions will work here. That's why the output would be an empty string, because that's the default you have to return if you're not able to achieve any rearrangement that can lead to two adjacent characters not being the same. So let's look at what are the possible approaches we can take to solve this question. By the way, I have explained the examples. You might have gauged that we need the frequency of occurrence of each alphabet first, which paves the way to our solution using a hash map, right? To use the hash map, I first put the frequency with the alphabets. So A will have frequency as 3, B will have frequency as 2, C will have frequency as 2. Say, suppose this is the example given to you. In that case, let me take the approach we took for example 1. We take A, then we take B, and then we take C. So we reduce the count for A to 2, reduce the count for B to 1, reduce the count for C to 1. So now we have ABC. Now we take another A and another B and another C. And so it's ABC, ABC, A. And your counts reduce accordingly. So this rearrangement works. So will this approach work for every solution? Let's look at another example. You have the frequency for A as 3, you have the frequency for B as 1, and you have the frequency for C as 1. In such a scenario, you take A, B, C, and your count reduces for A to 2, B to 0, C to 0. Thus, your output would be A, B, C, A. And you would say that since two A's are coming together, the output should be an empty string. But that's not true. There's a rearrangement possible for this, which would be AB, AC, or AC, ABA, in which all the adjacent alphabets are different. So how to achieve this? So the better approach is take the most frequent character each time, which is A in this scenario. So you take A, and then you take the less frequent ones, which could be a B or C. You take B. But then after that, you would say that after A, I could have taken the most frequent character again, I could have taken an A. So the hunch there is that put the previous character on hold. So if you take an A, which is the most frequent character, then you put A on hold because that is the previous character you have taken. And take the character which is not A. So you take a B or C. Then you check for the most occurrence of the character. So A, the count has reduced to 2. B, the count has reduced to 0. Whereas C, the count is still 1. So you take a C after A. And then the remaining character is A. So that's how you achieve this. So your algorithm should be you take the most frequent character each time. Then you put the character which you have taken previously on hold and take the next frequently occurring character. And that's how you're going to solve it. But is there a better approach to do this rather than using a hash map? Why am I saying this? Because every time you're checking for most frequent character in a hash map, that means you're going through the hash map and searching for the most frequent character. You're going through the values and finding the one which has the most count, right? The maximum count, which is itself of time complexity O of n square. In this scenario, if we assume that the number of alphabets is going to be fixed and it would be 26, in such a scenario, the time complexity for this solution would be O of 26 into n rather than O of n square. But will this solution be accepted by LeetCode? Is there a better solution possible? So we have a data structure which actually works well to find the most frequently occurring characters, and that data structure is MaxHeap. But when I'm doing the question using Python, you would say there's no default structure called MaxHeap in Python, but there is a min-heap. So we'll be using a MaxHeap to solve this question, and it's easier to solve in Java or any other language using a MaxHeap because they have a default data structure for MaxHeap, while Python doesn't. So in Python, we'll be using a min-heap, and then we'll be saving the character as well as the count. And since min-heap always takes out the minimum, what we will do is we'll make all the counts as negative. So instead of 3, 2, 1, we'll have counts as -3, -2, -1, and 0. So we will be taking out the alphabets unless their count reaches 0. And every time we take the character out, instead of decreasing the count, we'll be adding 1 to the count because we have taken negative of all the counts. So I hope you understand our approach. So we'll be using a min-heap rather than a MaxHeap because Python has a default data structure called min-heap. And for facilitating the functioning of min-heap as a MaxHeap, we'll be negating all the counts and we'll be adding 1 to count of the alphabet which we are choosing to take. Okay. And this takes our time complexity to search in a min-heap to O of log n. And our overall time complexity, assuming there are more than 26 alphabets, would be O of n log n. And if you assume there are just 26 alphabets, then time complexity would be O of 26 log n. So I hope the algorithm is clear to you. I know it's a difficult question and you might still be wondering, what is she talking about, right? Yeah, but keep your doubts on pause right now, go through the video again, and then watch my solution while coding it alongside me. It takes 1 or 2 goes to understand each nitty-gritty in this question. And if you have any doubts, ask them in the comments. I'll be happy to address it. So let's start coding this question and just clear this out. So first of all, I'll first initialize my count variable and I'll be using a default function called counter here. So this is nothing but actually a hash map for count for each character. Right? So that's the default. So I first got the count. Now this is just a hash map, right? But I want a maxi. So to do that, I initialize maxi and I'll be taking list and then a list. And like I told you, we'll be negating all the counts. So I negate all the counts and I take the character. So I'm taking basically minus count and character pairs. So I'm basically using a list comprehension for character and count in count.items. So I'm just doing a list comprehension of this and then negating on the count and saving them in a pair of count and character. Why count first and character second? That's because in min-heap, usually there's a tendency that it looks for this value and compares this value rather than the second value. So hence I have kept count first and then character. Now this is still a list. It's not a heap yet. So to convert it to heap, I will do heap dot heapify max. And this operation itself takes O of n time complexity, just for your reference. Okay. Now I will initialize my previous value because I need to compare my previous value and put it on bold. I cannot use the previous alphabet, right? So I'll initialize it with none for now. And I'll also initialize my result string by an empty string. The result string should be one rearrangement possible where none of the adjacent characters are the same. So I'll first initialize my result string. After that, I will run my while loop. So while either my max heap has been not null or my previous value is not null, this loop should run until then. Okay. Now I will check for the default scenario. Remember the example where you have the frequency for A as and the frequency for B as 1. In such a scenario, there is no rearrangement possible in which A will not be together, right? So I have to handle that scenario first. So what happens in such a scenario? Your heap has A as 3, B as 1. So you take the most frequently occurring character, you take A, then you keep A on hold because you just took A and you bring. After that, your count in max heap is B0 and A is not there because A is in your previous now. And your count in previous for A is 2, right? So your max heap has become null, but your previous has character A with count 2. So in such a scenario, your previous is not null or your max heap is 0. In such a scenario, you have to return empty string. So let me explain again. So what I did, I have A3, B1. I first take one character which is most occurring, which is A, and I put A on hold because I just took A. Then I take B. So my heaps count get updated. So A is not a heap anymore because A is a part of previous and B's count is 0. This is your heap now. And your previous would be A with the count as 2. So this A count of 2 will be in your previous. That's how you keep on updating your previous. So you can see that your max heap is null here, but your previous is not null. In such a scenario, there is no solution possible where the most occurring character will not be adjacent, because then you have to take an A from previous and then push it to heap and then again an A. So in such a scenario, you have to return an empty string. So that's what I'm going to do here. So I will check if my previous is not null and my max heap is null. So if that happens, that means there is no rearrangement possible where two characters adjacent to each other would not be the same. So I'll return empty here. So I've handled this default situation. After that, I will find the most frequent character except the previous one. So I don't want the previous one, right? That's the solution, right? Every time I look for the most frequent from the max heap, but I have to keep the previous on hold. So I will check for count and character, and I use another function of heap, which is heap for. And since it's a min heap, I will do max heap here, the name, but the count is negative, right? So you got it what I need. After that, you will add this character to your result because you have popped it up. And you will also increase your count because your counts are negative. That's why you are increasing. If there would have been a max heap default data structure in Python, then you would not have negated all the counts. And in such a scenario, you would have taken count minus equal to 1. But that's not possible. Hence, we are adding 1 to the count since we have negated all the counts here. So I hope you understand it. Now, I will check if there is a previous value. That is, your previous is not null and there is a previous value already there. So you cannot overwrite it. You first have to push that previous value to heap. So I will use another function of, and I'll push heap, push max heap. So I'm pushing it to max heap, and what I'm pushing to max heap, it's the previous. So, and I will set my previous to none. After that, I will check if my count is not equal to 0. You can use the condition count less than 0 as well because all the counts are negative. So if my count is not equal to 0, in such a scenario, your count is here. So if my count is not equal to 0 or it is less than 0, I will push that value to previous. So I will push count and character to previous. And I have handled all the scenarios now. I can just return the result. So I'll return the result. So I'll run my question. It's accepted. Let's submit. So you can see the solution is doing really great here. The time complexity is of 26 log n. if you assume there are only 26 alphabets. If you assume that there are n alphabets, so its time complexity would be of n log n. But let me explain the question again, since it's a very complex question. I don't want to leave you hanging here. And if you still have doubts, I would suggest you go through the video again, or you ask the doubts in the comments. I can go in detail with the question wherever you have doubts then. So let me explain the question. For we first need the counts or occurrences of each alphabet. For that, we use the counter function from Python, and we did count is equal to counter s. After that, I initialize my max heap variable, which is not a heap right now. I'm just doing a list comprehension and creating a list. So here I create a list of minus count comma character because there is no max heap in Python. There is only a min heap. So to make a min heap work like a max heap, I'm negating the counts, and then it pulls the minimum value from that heap, which is actually the maximum count if multiplied by -1. So we are basically working with the min heap using negative counts. And I take the list minus count comma character for character and count in count.items. That's how you use list comprehension. Now I have created the list out of maxi. I will just heapify it to convert it to a heap. So until now, I hope it's clear. Then I initialize my previous value with none because we need the previous value so that we can keep it on hold whenever we have used that value just now. Okay, so that no two adjacent characters are the same. I also initialize my result value with an empty list. And then I run my while loop. That while loop will run when either your previous is not null or your max heap is not null. It will run till then. But I have to handle one scenario where where your rearrangement is just not possible, which is similar to like when your A frequency is 3 and your B frequency is 0. In such a scenario, there is no such rearrangement possible where your two adjacent values will not be equal, will not be the same. Okay. So in such a scenario, like I explained earlier, your max heap would have turned to null, like your counts in max heap would be null, zeros, whereas your previous would be not null. So an empty string. Now, if that scenario is not true and you can process and get a rearrangement, you pop the value from max heap and store it in count and character variable. And then push that character, you add that character to your result, and then you increment your count. Because you have already popped it once, right? You have used it once. Or since you're using min with negative counts, that's why you're adding one to the count and not decrementing it. After that, you check if your previous value is not null. In case it is not null, you have to first push that value from the previous to the heap. That's what I have done here. And then you reset your previous to. Now, once you have reset your previous to none, after that, you go and check if your count is not 0. That is, your count is still less than 0, count is still negative. That means you still have that character and count. You add that to your previous because you have just popped it. So you need to put it on hold so that you don't use it again, so that no two adjacent characters are same in your rearrangement. That's what you're doing. So you save the just popped count and character pair to previous after you have set previous to null. Okay. And then you finally return the result. So this will work for your solution. You can test it. So for example, you have A as 3, B as 1, and C as 1. In such a scenario, you have already heapified and your counts will get saved. So your A's count would actually get saved as -3. B's count will all actually get saved as -1. And C's count will actually get saved as -1 in your max heap. And your previous would be null. Your result string would be empty. Now your heap is not null. You can see your previous is none because you have initialized it as none. And you go through the loop. Here, this condition is not true because your max heap is not null, right? So you go through this and you pop the most frequent. Your most frequent is A, when -3 is the count, right? So in such a scenario, your count comes to be -3 and your character comes to be A. So you add it to the result and your result becomes A. Okay. And then you increment the count. After that, you check if your previous is not 1, but your previous is none yet now, and your count is not equal to 0, it's less than 0, right? So your previous gets set to -4 and 8. And your max heap right now, since you popped A, your max heap has two lists, and one list has the count -1 and B, and the other list has count -1 and C. So now you check for the next most frequent in the heap, which could be B or C. So you pop B. Okay. In such a scenario, now your count gets set to -1 and your character gets set to B. After that, your result A, B. Okay. And then you add that count to previous, but your previous is not none. Your previous has this value -4A right now. So since it's not none, you push it to heap. So your max heap now becomes -A, but you have to add 1. Sorry, I made a mistake here. It's not -4, it will be -2. I subtracted 1. You have to add 1 here. So your max heap become -2A and -1C. And then you can push this count -1 and B pair to previous because it gets set to none. But you have to add 1 to the count here, right? So -1 plus 1 would be 0. But you cannot set previous 0, comma B because if your count is not 0, then only you will set the previous. Otherwise, your previous becomes null. So it will remain null. Okay. So now your heap is this, your previous is none. You again go through the loop. So the most frequently occurring one is -2A. So now your count is -2 and your character is A. Then your result gets set to A, right? You add 1 to the count, so your new count would be -1. Okay. And your max heap, since your previous is none, so nothing to push to the max heap. Your max heap right now is -1, comma C. There is only one pair there now remaining. And now, since your count is not null, it is less than 0, your previous gets set to -1, comma A. So now you push, now you check for max heap and your max heap is -1, comma C. So you pop it. So your new result becomes A, B, A, E, and your count would be, since you pop that count -1, comma C pair, your count would be -1, but then you have to add 1 here in line 17. So you add -1 plus 1, which will be 0, and your character would be C. That's what you have added to the result. But your count is 0, so you cannot add it to the previous. And your previous is -1, comma A, so you have to add it to the heap. So your max heap becomes a list of -1, comma A. So now you pop it again, and your result becomes B, C, A. The count which you popped was -1, but you have to add 1 here, so your count becomes 0. And finally, you have reached the end of loop. Your result is this, and you return the result. So I hope you understand with this example how this loop is actually working. And the time complexity would be O of NlogN, assuming that there are n alphabets and not 26 alphabets. If you assume there are 26 alphabets, the time complexity would be O of 26 log n. Subscribe to my channel to get your notifications for a daily LeetCode challenge. Thank you.